Hello guys, greetings. I'm so glad you made it up to this point. In our quest for a suitable environment, we've embarked on a journey on how to use GIS environment to model a suitable location for our renewable solar energy, our wind energy, and carry out some other spatial and sustainable analysis. Okay, and we mentioned in the introduction that we're going to be using 10 criteria, that is coupled with GIS multi-decision making process, and using analytical hierarchy process. And in several other videos I've shown you how to download all these criteria one after the other for free, so you don't need to subscribe or buy into any packages, before you can gain access to all this data. So, and I also explained that it's going to be a baby step-by-step approach. I'm going to walk you through all that you need to know as a beginner or as an advanced user of our GIS environment to develop or solve a real-life scenario. Alright guys, at this point, let me quickly give you an overview of what our end result is going to look like. Here we have the southwest region of Nigeria, which comprises of 6 states. This is the boundary of each of the states. Now I'm going to add the 10 criteria one after the other, and I'll be starting with land elevation. Okay, see what we've got. You can see on this side, that is below sea level, then highest side on the northern side. Okay, see. Then the next thing I'm going to have the aspect, this is the slope aspect. Then we have the slope itself. Okay, the highest on the northern side, the lowest on the southern side. The next thing we'll have the soil texture. Then we have the land use classification. You can see the build-up area, the urban area, the rangeland, and the crop vegetation and all that. Then we had distance to major road, alright, distance to power grid, distance to build-up area, the global irradiation horizontal. You can see the lowest value on the southern side and the highest move towards the northern side. Okay. Lastly, we have the temperature. Alright, you see the lowest on this side and the highest temperature value on this side. So now that we have all the criteria ready, the next thing is to apply weight to them. That is the degree of importance. We have this as our final end product. Okay, see all criteria applied. Alright, then we resolve at this. Now we are going to apply the restriction, that is the areas that we don't want them to participate in the final results. Alright, and that we have applied the restriction, we now have the final suitability showing that the northern side possesses the highest suitable area because these are the regions that meet some of these criteria, okay, for the most suitable area to set up a solar farm. Alright, so we are going to go further in the analysis by defining the suitability potential of each of the states, as you can see in the display. Alright, so we will now know the energy potential defined in terawatt hour per year. Okay, after which we are going to go further to determine wind energy suitability for the same study area. Alright, and we'll go further to perform hybrid suitability analysis, that is area suitable for installation of both solar farm and wind farm to enhance energy production and also reduce costs and promote efficiency. Okay, so let's get into the work. Alright guys, at this point now, all we need to do is to grab a cup of coffee and sit down because we're going to go deeper into the data engineering and processing now. And the first thing on our list is to do some housekeeping, and we are using a GIS 10.8.2 for this tutorial. Okay, you can use any GIS of any version of your choice, but for me I'm using this 10.8.2, and this is the ArcMark environment, that is extension of the package. And here I have table of content which shows the layer as we bring them in as we walk along, and this is the working environment. On this side I have a toolbars already pinned down here, so you can always get your Arc toolbars. If you don't have it already pinned down, you can do so because you'll be using it a lot. Okay, and now the first thing we are going to do is to do a geoprocessing now. But before that, let's try and add some of this data that we've downloaded in previous video. Okay, and so let's try and add them from this side. That should be better. We add them here. You use the add, that's the plus sign, so you also get the folder. All right, so you're going to add the soil texture, land elevation, land use. Okay, in the downloading we did for this land use, they are in slides. Okay, you can pick up the video, watch on how to download for this data for free. All right, so and again we are going to be bringing in the global horizontal irradiation, and that is saved here with the temperature. This is it, that is solar irradiation with temperature. We'll be needing that as well. And okay, we also need to bring in the grid network. We also have it here. Okay, so main grid, that is from grid finder. All right, so I will be dropping in the description of this video links to download all these data for free. Okay, you don't need to subscribe, you download them all for free. Okay, that's the grid network for the entire world. So we'll be clipping shortly. And now we have land use 1, 2, 3, 4, 5, 6. Okay, we still have other data to bring in. Okay, we have here the boundary. Let's bring in the boundary of our study area. That's the southwest Nigeria. We had it. Okay, that's the region we'll be clipping to as our study area. And then in another video we downloaded the OpenStreetMap for the whole of Nigeria. From there we can gain access to the railways, the roads, there's the water, free, and that should be it for now. So we click add. You can watch the video on how to download from OpenStreetMap. Alright, let's keep the boundary up. Okay, let's collapse everything. Let's turn everything up so that it will enhance the processing time and all that. Turn them off. So for the southwest, this is the boundary now. Let's try and keep it as a holo. You can click on this symbology, then you change it to here holo. Let's change the color to red. Let's increase the width 1. That's it. Now that we have seen all this data that we'll be using to derive the necessary criteria, which is the 10 criteria for the analysis, let's first of all clip them to this our specific study area. And before we do that, let's try and do the geoprocessing setting. When you click on geoprocessing, you go to environment. Okay, in the environment you first look at the workspace. Okay, make sure you select the create or okay that we are going to create shortly. All right, because if you go to the root of the folder, this database already existing, that is grid. We downloaded this straight from the internet, and this southwest boundary just use housekeep the boundary. Okay, so we are going to create new for all our data sets to be kept within a geodatabase. So you're going to come where you have new file geodatabase, click. So let's give it a name. Let's say SolarPV dbase. Okay, you don't really need to do much. Then you select it and add it as the current workspace. Okay, so any processing you do are going to be saved directly inside this workspace. However, you can always specify at the point of processing where you want the file to be saved. So the same, we're going to keep this crash in the same environment. Add. Okay, that's it for workspace. Then you're going to where we have processing extent. So the extent now is going to be our southwest boundary. So we don't want any processing to go beyond this boundary. All right, so we're going to snap the raster when it's, let's say we snap the raster to our temperature. Yeah, that should be fine. You could either use global horizontal irradiation, but I'm keeping it temperature for this. And then we go down to where we have raster analysis. Let's say set size should adopt the same as that of the temperature. It's fine. So, and for the max, let's max it to our particular boundary, southwest boundary. That should be fine. Then we're going to click OK. That's it for this geoprocessing setting. Now we've set the environment. Click OK. Let's customize and give access to the license. We do that by coming up here, customize. You go to extension, Okay, under the extension, you make sure that spatial analyst is checked. If you don't have it checked, you do so. Now I have it checked in my case. I'm going to close it. Then for the display, we going to right click this working environment to be sure that we have a correct display within the data frame. Then you're going to go to data frame properties, projected coordinate system, you expand it, then you go to UTM, then you go straight to where you have WGS 1984, because all these data we have here are in geodetic coordinate system, that is the longitude and the latitude. So we want to have the WGS 1984, that is the same datum. So you're going to select northern hemisphere because our study area is under northern hemisphere, zone 31N, which is north. This is it. You select this. Okay, now that we have the data frame coordinate displays projected to UTM coordinate system, we are going to start clipping the boundary, and we'll be utilizing the model builder. Okay, so you come to where you have catalog, you locate to the folder, the root folder where you're working, connect to it, and then this is, you open it. We are going to right click here on the root folder, then go to new toolbox, then you name it, let's say SolarPV tools. All right, so in that toolbox you're going to right click again, you go to new, then you click on model. So new model builder has opened up here. So you are going to open the actual box here that we have pinned down here, because we are starting with a raster clipping. So you are going straight to data management tools, you expand it, you go to where you have raster, expand it, raster processing, you expand it, then you see clip. All right, you drag it and drop it in the model builder environment. You're going to double click, then you can now key in the input raster. In this case, we're starting with global horizontal radiation. Then the extent is going to be our boundary. Then we make sure you check this to keep the clipping within that boundary, that is the shape of the boundary, the geometry of the boundary. Then as for the output raster data set, we keep the name as this, and this remain as default. Then we click OK. All right, let's have it view. Okay, we have it here. All right, and we have other raster data that we need to do the same for. I'm going to go ahead and do that. All right, so now we're going to do the same thing for the other raster feature. Okay. All right, so I've created the clip for raster feature. It could have been 5 at this point in time, but as for the land use, we have it in 2 slides, so we need to mosaic or combine the 2 slides before we can handle them independently. Okay, so as for the one we have clipped so far, let's try and run the model simultaneously, and we do so by using the play button here, run. Okay, the running has begun, then we'll wait that everything is done. All right, good. It's completed, and the whole clipping took 1 minute 28 seconds. All right, so we are going to close this. If you like, you can add them to the display so that you see how it looks. Okay, let's just quickly add the global radiation to display. You right click, then you go to add to display. If you don't want to go and grab the file itself from the geodatabase, you can just add it to a display. Let's see how it looks. Okay, now you can see everything clip within our specified boundary, that is our study area. All right, so now we are going to clip for the vector data type as well before we now come to merging this or mosaicing this land use. All right, because if you look at the land use, they are in strip. This is the first strip, this is the second one. Okay guys, now that we have our raster clipped to the boundary, so let's do the same for the vector data type. All right, bring up the model builder. So on the app toolbars, you are going to where you have analysis tools. All right, different from the way we extract for the raster. All right, so and under the analysis tool, you are going to expand extract. Okay, then you see clip, you drag it into the model builder, double click. For the first one we have on our list here is railway. Let's just pick them one after the other. Then we'll select railway. The clipping feature will now be the boundary. Okay, let's do it separate. The boundary. Then let's leave the name as say railway clip. It's fine. Railway clip. We'll leave the rest as default. Okay, and then let's do the same for road. Double click, select road, clip it to the boundary as well. We use the same. Then let's name it as a road clip. All right, we'll leave the default. All right, and then we're going to do the same for grid. That is the power grid. That's power grid clip. We leave the rest as default. And then lastly, on the vector is going to be water. So water clip, we leave the default. So now let's run the clip from the 5, clip 5 to clip 8. All right, remember we run the other clip simultaneously by using the run button here, but as for these other ones we are going to run them independently, because if we click on the run here, it's going to run all over all these other clips that we're already satisfied with the result. Okay, so to avoid duplicating the file and taking much of our time again, we run this independently. So we are going to right click on the clip that is the setting environment, one after the other, then we click on run. So we wait for this to complete, then we'll do the rest. Okay, done. We do for clip 6. It's taking a little bit of time because the features are many, like a road network, several polylines and all that, so that's why it's taking longer than the railways. We allow it to finish its thing, then we come back. All right, all done, completed. Then it takes about 5 minutes or 50 seconds to complete, so we close it and let's run the power grid as well. Done. Let's run water. All done. All right, so now that we are going to try and click the land use, but before we do that, we're going to mosaic to become one raster. Okay, it's 2 raster now in the slide, so we have to bring them together to become a singular raster before we can now click. Okay, so we do so by going into under data management tools. Okay, data management tools, we go under raster, then we go to raster dataset. Okay, you see raster dataset, then you now go to mosaic to a new raster. Okay, you drag and bring it up, then you open it up, and now it's going to ask you to input the raster, the first one, then we input the second one. All done. As for the output location, we're going to create a file, a folder outside the geodatabase. Let's create new folder. We name it, let's say land use. Okay, so inside this folder we'll be keeping the converted land use or mosaic land use. So we select the folder we had, and as for the raster dataset with extension, that is the name, let's say land use.tif file. Then for the pieces we leave the default, and for the band, if you check the property of the land use, they are in a singular band. Okay, so you just put 1, but if you are clipping any features or mosaicing any feature rather, you must be able to define the band before the clipping can process. So you do so by just checking the property from the features layer that is on the table of content. So we're going to apply all good, then we click OK. So now we are going to run this independently as well. Okay, all done in about 3 minutes. Going to close it. Then let's see how it looks. Let's keep the layout. All right. Okay. Now let's see how it looks. I'm going to add to display. Then you see it's taking the extent, that is the extent of our study area. All right. And mind you, it's not taking the clip, that is the boundary, the exact boundary. Okay, and the reason why it's taking this extent because we have done the geoprocessing settings to maintain our work within this extent. All right, so don't be confused if you need more than this extent and you are trying to mosaic and you're getting this kind of result. Try and change the extent, or you take it to default that you should process without clipping to this particular extent. All right, okay, so now the next thing we're going to do is to clip to the boundary. All right, we do so by going under the data management tools as well, raster processing. We expand, then we go to clip. All right, oh sorry, bring up the model builder, then we'll bring in the clip. You open it up, then the feature, that is the raster, is going to be the land use. Then the extent will be southwest boundary. Let's keep it like that. Then we make sure you click to this. Oh good, let's leave the default, then you click OK. Oh okay, to be certain that you are using the right land use, okay, you go back. Remember, when we want to select the input raster, we actually selected this, that is the layer, but we are going to select from the model now. If you are using the model, which is this, it's going to use exactly what you have, that is that you just process, and everything is going to be linked together. Okay, let's apply. Okay, now we have it updated. Okay, move this aside, we can take off this, don't need it. Now we have it updated. Okay, we are going to run this independently. Okay, hold on, in about 4 minutes we're going to close it. So now we have all the clip done. The next thing is to make sure that all our data are presented in the acceptable format, and the acceptable format for this advanced analysis that we are working on is presenting all the data in a raster format. Okay, so we have few of them already in raster, and for those ones that are not in raster, we're going to make sure we bring them into raster format, and we do so by their first projecting the coordinate system. And the essence of projecting the coordinate system of this line feature is because the raster we are going to be working on has to do with the distance between each other, that is it to enhance the reclassification, yes, of the raster. Okay, because the analysis want to define a boundary of reclassification, that is the suitable, most suitable, and the moderate suitable area, like that. So we, in order to maintain the standard unit like kilometer and meters and all that, we need to project it into a UTM or UTM coordinate system in order to achieve that. So we are going to do that right away, and also we'll be using the same data management tools, projection and transformation. Okay, and we're going to expand this, and then for each transformation or projection we need to do, we need to be sure we are using the right one for the raster, and for this one is for the vector. Okay, so if it's raster, you expand this and use what we have here, project raster. Okay, but now we want to talk about the vector, and we are going to take this project, you drag it in, then we feed in the data set, that is the feature data set. We're starting with railway. Let's pick it first, then we are going to leave the name as a default, railways clip project. For the coordinate system, we will be using projected coordinate system, UTM. So we're going to expand this projected, okay, and we go straight to where we have UTM. Now under UTM, we are going to expand there, that is WGS 1984. Okay, remember, if you look at it up here, the one we are using is geodetic coordinate system, but it's still the same datum, WGS 1984. So we need to maintain that datum. So that's why we are going to use the same WGS 1984. We expand it. Our study area is our northern hemisphere. Okay, so we're going to expand for the northern hemisphere, and we're going to go straight to where we have the right zone, which is zone 31. Okay, so zone 31 north is you select and you click OK. All right, so and that is it. In case it didn't come like this for you, maybe you were not unable to select your projection, it could be that you can have some error if the two are not on the same datum. So you need to do transformation to make sure that the two are in the identical datum before you can proceed. All right, so you click OK. Now for this railway, let's run it independently. Run. Done. Okay, let's see. And where is it? Okay, this is it. So the same we do for the road clip. You open it, select the road clip. Yes. Then the coordinate system, you do the same. Projected UTM WGS Northern Hemisphere Zone 31 North. Okay. Okay. You run it. Okay. Hold on. Close. Then we're going to do the same for the remaining two. Okay, so now we have achieved the projection. Then we are going to convert now to raster, and we're going to do this by using Euclidean distance. Okay, and we look at the vector we have here. They are 4 in number, but as for those ones that are going to participate as part of the 10 major criteria, it's going to be road, that is the major road, and the power grid. Okay, all these other ones will come in when we want to do restriction modeling, but for the major criteria now is going to be road and power grid. So we are going to focus on these two now. So let's start with the power grid. So we are going to do this by going under the spatial analysis tools. Here we open it, then we go to where we have distance. Under the distance, we look for Euclidean distance, which is this. We drag it and bring it in. All right, so now we are going to open the input raster. Now is going to be, for the first one we are doing, is going to be power grid clip projected. All right, so we're going to select it from the option. All right, here. Now we are to input a raster or feature class, that is barrier. If you have any raster that you want to exclude, we don't have anyone at this point, then we leave it. And the output cells is going to follow the one that we specified during geoprocessing setting. All right, so and we look and for the method we leave it as a planar, and the other remain as default. So you click OK. Power grid, that is power. Let's add it to display. Okay, you can see now. Let's see. You can see how it looks. It's been classified. That is, the power grid has been classified into 10 classes. Okay, we'll be doing reclassification later in the future into 5 classes in this analysis. All right, so we go to the next one now. Okay, now that we have achieved the Euclidean for the power grid, and as for the road network, that is, if you open it up, let's bring it in view, display. Okay, let's check. Okay, the road network contains all the road classification within our study area. Let's open up the attribute table and we'll see what we've got. Now you see the feature class, and it contains all the road classification. However, this study is limited to only major road in this study area. So the major road we are going to be looking at now are going to be where we have primary road, tertiary road, trunk, major road, motorway, and all that. Okay, so in order to be able to achieve only this feature, we are going to use selection by attribute. All right, if you come up here, selection by attributes, you open it up. All right, so you make sure that you select the right feature that you want to select from. Okay, and you select the same way, the right key that you want to select, that is, you want to the right layer you want to select from. So we are selecting from F class. You double click, then we are going to write this simple SQL syntax equals, that is, select from the map road clips project, where F class, that is the feature class, is equal to, we're going to get all the unit value that are for this feature. Then you click on get unit values. So the process is running through this entire number of features. You can see 323121. So now we have all the unique value. Like I mentioned, we are going to include motorway. Then you have gotten this. The link as well has to go with it, as the same for others. So you're going to add multiple selection now. You're going to use or syntax. You use or here. Then you do the same as for the motorway, which is F class equals to motorway link. Okay, now we've gotten that is in view. Then you add more or, because they are multiple, we are bringing them as a single selection. So the next one was going to be the feature class equals to primary, then or again the feature class equals to primary link. Then we look at we leave aside this residential, we look at secondary the same way, or F class equals to secondary road, or F class equals to secondary link, or F class equals to, we have tertiary, or F class equals to tertiary link, or what else? Okay, trunk. Let's pick this equals to, that is F class equals to trunk, or F class equals to trunk link. All right, we leave the rest. So let's see if the syntax is actually correct. All right, you do so by clicking on verify. Okay, you can see the message. It says the expression was successfully verified. If there's an error, it's going to tell you. Then you can take a look again and make sure you correct accordingly. So, and then now that it's verified, you click apply and okay. Okay, you can see in view now all the road in category selected. So to create a new layer for this selection, you are going to come under the feature from the table of content. You come under that layer, then you going to right click and go to where you have a selection. Then you go straight to where you have these create layers from selection, and all is done. So you've created a new layer from this selection. So in this new layer now, is only within this we are working environment, but we need it to be right in our database, your database. So we are going to do so by right clicking again. Then you go to where you have data, then you go to export data. All right, so you're going to open up this browse folder icon. Then here we are already in the geodatabase. Make sure you select the right geodatabase and the feature class. So I'm going to name this as a major road. Major road. Okay, save. Okay. So it's going to extract or export the feature into the geodatabase. Now it's asking us, do we want to add it? Since it's just a new feature for us now, we can add it, yes, to the layer. Then we remove this old one. All right, we don't need it, it's not saved anywhere. We remove it, and we can as well uncheck this, or before then let's clear the selection. We clear the selection, then we uncheck. All right, so now you see the major road in view. And let's go back to our model builder. So we can now perform the Euclidean distance for this new feature now, which is major road, and we do so by bringing in the Euclidean distance. You double click, select the road as, that is major road, as the input raster. Then let's give this as a Euclidean major road. Okay, then let's click on okay, others remain as default. You click okay, no barrier. Now you run this independently, close. Okay, Now all done. All done for this. So the next thing we're going to do now, let's try and keep in view or keep in check the features or the criteria that we already have so far. Okay, so we know the one that are missing, then we can go right from there. Okay, from my calculation, I see that we have the major road, the land use, power grid, then others. So what is missing now is slope and aspect. Okay, and slope are aspect as a byproduct of our elevation. Okay, so we're going to get those ones right from elevation feature. So okay, this is our land elevation feature, and we're going to achieve our slope and aspect by going right under 3D analysis. There are other ways of doing this, but we prefer to use the 3D analysis. You expand it or open it, then you go to where you have a raster surface. You expand it, then you bring in the aspect, you open it up. Okay, you make sure you select the right feature, which is input raster, and this one will going to be elevation clip. All right, land elevation clip. Leave the rest as default land at aspect land elevation 1. Click OK. Then let's see, we have it here. Should be down. All right, so we're going to run this now. Run. Okay, all done. Okay, the same we do for slope. We bring in the slope, select the right input raster, which is our land elevation clip here. Then the z factor wasn't defined. Okay, and the reason why it's giving us this error message, the z factor, is because the projection is in geodetic coordinate system. All right, when things has to do with height, distance, and 3D, basically you need to have it in a UTM coordinate system, okay, before you can eliminate all these error. Okay, so let's quickly do that before we come back to this. Let's cancel. For the land use, let's quickly project it. Remember we did projection for the other one in our data management tools. Then you go to projection and transformation, but this time around you're going to select raster. That is raster project or project raster. All right, bring it in. All right, select the right raster, input raster, which is going to be land elevation clip here. Then the coordinate system is going to be the same as projected UTM, and then the same datum, northern hemisphere 31 n. Okay, 21 not good, and you click OK. Leave order as default. Okay, and you run this first, but okay, let's run the two together simultaneously. So we can now go for the slope. Now remember the new name of the projected raster now is what we're going to select, which is land elevation clip project. All right, select the right one. Now you can see the z factor is gone. That error message is gone. Okay, so we click OK. You can see this has no shadow, meaning that we are yet to run this particular algorithm. So in order to achieve these two simultaneously, we're going to run this one now. Then make sure that you fetch all the necessary input data to make sure that get the result for the slope land elevation. So you're going to run slope. Now you can see it's executing the project raster, which is this. It's doing the projection now. After the projection, you can now do the slope. All right. All right. So hold on. I'm gonna click close. Okay. So the final criteria for that is the major criteria now is our build up area. Okay. And then we are going to utilize this feature, which is the land use feature. Okay, the land use, if you check the land use, let's bring it in view after the display. All right, okay, let's uncheck this. Okay, if you are familiar with your study area, you can see that so the land use are being symbolized as red in this case. Okay, you don't need to guess anyway. You remember where we downloaded this file, that is the land use, the legend has been provided. Okay, you can just go through the legend to know the right symbology or the right feature. Okay, if you expand it, you can see there are a bunch of features here. You proceed with your classification and all that. Okay, so we are going to get our build up area from this feature, that is the land use. So and the focus is we just need to extract only this particular one. So we do so by going to, let's open up our model builder. Then let's see. Okay, everything is nice and clean. You can always use auto layout to keep everything nice. All right, so let's somewhere up here, let's go to where we have okay, special analyst tools. Then you're going to open extraction. Under the extraction, you're going to extract by attribute. You bring it into the model builder environment, you double click. So as for the input raster, you're going to select the land use clipped, right? This. Then now for the clause, remember we we are interested in the build up area. So the legend for the build up area is 7. That is the value for the build up area is 7. So we use value equals to get the unique value. Okay, now you can see that the unique value has been inactive. Okay, when you come across situation like this, I'm going to show you how to get rid of it. Okay, you do so by, let's cancel this first. You cancel this as well. Then you go straight to where you have land use clip. You're going to, that is the feature, you're going to right click, open up the properties, you go to your symbology. Okay, you go to symbology tab, then you make sure that you look for classify. And as for the classify, or no, let's use unique value instead. Yeah, so it's going to build a raster table. Okay, so it's going to build the unique value. Now you're going to click yes. Okay, now you can see every other one that has no count has been eliminated. So in this case, you can just click OK, or you try and adjust the symbology. Okay, and then if you see the value now, you can see you have those ones that have number of count. So you go back to your extract by attribute, you open it, go back to select the same layer, which is the land use clip, and then you go back to clause, then you open this, double click value equals to get the unique value. Now you see, so you select 7 on verify, is good, successful, then okay. So you can okay here as well. Now you run this independently. Okay, all good, done, close. If you want to see, and right click at the display. Okay, now we have only the urban area in view. Okay, let's try and rename it. Yeah, go back under extract, let's remove this. Then let's rename. Okay, we call it built up area. Okay, all right, that's good. Let's check it, add it to display. All right, so you have it built up area. So let's close it. You can see, so is this build up area that we're going to perform buffering for as well, and this one is still going to follow the same Euclidean distance. Okay, and that means before we achieve Euclidean distance, we need to make sure that this raster has been presented as a vector data type. Okay, so that means we need to convert it to a polygon. All right, that is a vector. So, and we do so by going to conversion tools, and let's close this. Right, You open up the model builder again, keep it nice, then you expand in the toolbox conversion tools, and remember we are converting from a raster to a vector, so it's going to be features from raster. You open up from raster and you are converting raster to polygon. The reason why we need to be careful of the one we select is because we need to know the features that we are interested in. In my case now, these features are in a cluster format that does not have a continuity, or maybe the lines are not being connected in that manner. So I will need to bring them into a polygon, okay, so they can stand independently. For instance, I'm working with a road feature now. I will be using raster to polyline, line feature. So for that is more like a cluster and all that, so I'm using raster to polygon. So you bring it in, you open it up, make sure you select the right input raster, which is the build up area. We save it as build up area, the value remains the field optional, so every other thing remains simple polygon. Then you click OK. You can run this now. Okay, in a situation whereby you come across this kind of error message, you can see is a general error. That is where you have 999999 is a general error in ArcGIS environment that you can't actually define the cause or where you've missed it. But I'm going to show you one of the way of getting rid of this kind of error when you are doing this similar analysis. Okay, you can see that the error says it fails to execute raster to polygon, and we can fix this by going to geoprocessing settings. Let's close this. And what are we going to do in geoprocessing setting? You remember when you open up the environment, so environment settings now, you remember at the start of this tutorial we define our workspace. Fine, good. Processing extent is good. Now if you now see where we have snap raster, is saying temperature, snapping it to temperature. But this time around, in order for this extension to communicate properly, we just need to select this particular raster that we want to work on, which is a build up area. So instead of temperature, we're going to select build up area. Okay, and then that is for extent. Then the raster analysis, we're going to make sure that is masked to the same environment as well. So let's just say we want the mask to also be the build up area. Okay, so just click OK. That's it. Now let's come back to raster to polygon and rerun. Voila, it's processing. Now we have our results. Okay, so you can click OK. Let's see what we've got. Let's add it to the display. All right, perfect. This is lovely. And now that you have the raster to polygon achieved, you need to go back to the environment setting. So you go under geoprocessing environment again. Make sure that you return back the setting to what it was before. Those are changes you made. Take them back to what is very important. So, and we're going to take it back to temp now. As for temperature, then that is for the under the workhouse, but we did nothing there before. Then processing extent, we're going to take the snap raster back to temp, and then for the raster analysis we take it back to the study area that it was before. Okay, which is southwest boundary. Fine, then you click OK. So, and the next thing now is to achieve Euclidean distance for this build up area. Okay, and we do so by going under the spatial analysis tools again. Then you expand distance, then you can have distance, bring it to the model, double click. Then the raster now is going to be your new raster polygon. Okay, yeah, build up area. And as for other things, okay, output, let's try and rename it as raster build up area. Then no barrier, output sets remain, and planar, because this output set now is adopting whatever we set in the geoprocessing. So that is why we need to go back and take it to what it was before, because we are going to unify our data sets. Okay, that is the pixel size, we want to unify them, and you are still working with the same raster, which is build up here. So that's why you still need to go and readjust the geoprocessing. So as for the method, it's remained the same. Click OK. Then you can run this independently now. Run. Okay, it's done. Close. Let's see what it looks like. Build up here at the display. All right. Okay, let's see. Perfect. See what it looks like. All right, good. So let's uncheck this. Now we have all the 10 criteria in view. So I'll be adding them one after the other. From there, we'll do the next analysis.